question at hand involves the installation of a 12-volt track lighting system, specifically whether the inspector's requirement for sleeving the low-voltage wiring with greenfield or flexible metallic tubing is valid. The inspector's argument might stem from National Electrical Code Section 501.6c, which states that flexible or armored cable shall be used in lengths not exceeding 6 feet or 1.83 meters, where the cable is subject to physical damage. However, this section typically applies to hazardous locations and may not be relevant in a standard residential kitchen remodel. Their argument rests on National Electrical Code Section 725.158b2, which directs the Class 2 and Class 3 circuit shall be installed in accordance with Articles 725 and 727. Article 725 pertains to remote control, signaling, and power-limited circuits. Importantly, the National Electrical Code does not generally mandate conduit or flexible metallic tubing for Class 2 circuits which operate at 12 volts or less with concealed wiring. Class 2 circuits are defined as those with voltage and current limitations that reduce the risk of electrical shock and fire. The inspector's interpretation appears to be incorrect in this scenario. The National Electrical Code provides specific guidelines for low-voltage wiring, and these guidelines often differ from those applied to standard line voltage circuits. To resolve this issue, provide the inspector with the relevant code references, specifically those pertaining to Class 2 circuits and their installation requirement. If the inspector persists in their disagreement, you should consider contacting the local authority having jurisdiction for clarification and a formal ruling. The authority having jurisdiction is responsible for interpreting and enforcing the electrical code within the specific locale. To further elaborate on the relevant code sections, it's essential to understand the distinctions between different classes of circuits as defined by the National Electrical Code. Class 1 circuits operate at higher voltage and power levels, and their installation requirements are generally more stringent. Class 2 and Class 3 circuits, on the other hand, are designed to minimize the risk of electrical hazards. National Electrical Code Article 725 outlines the specific requirements for these circuits, including limitations on voltage and current. The fact that the track lighting system operates at 12 volts, which is well within the Class 2 voltage limits, is a key factor in determining the applicable insulation requirements. It's also important to consider the type of wiring used. While the question mentions 12-2 Romex cable, it's crucial to verify that this cable is appropriately rated for low-voltage applications and that it meets any specific requirements outlined in a product listing or instructions for the track lighting system. In some cases, the manufacturer may specify the type of wiring that should be used to ensure proper performance and safety. Furthermore, the installation must comply with all other applicable requirements of the National Electrical Code, including those related to wiring methods, overcurrent protection, and grounding. While conduit may not be required for Class 2 circuits, it's still important to ensure that the wiring is properly supported and protected from physical damage. This may involve using cable ties, staples, or other appropriate means to secure the wiring in place. If there's a concern about the wiring being exposed to physical damage, additional protection may be necessary, but this should be based on a specific assessment of the installation environment. For example, if the wiring is located in an area where it could be easily stepped on or damaged by moving objects, it may be prudent to provide additional protection, such as installing the wiring within a raceway or using a more robust type of cable. To summarize, the inspector's requirement for sleeving the low-voltage wiring with conduit or flexible metallic tubing appears to be inconsistent with the National Electrical Code requirements for Class 2 circuits. By providing the inspector with the relevant code references and, if necessary, contacting the local authority having jurisdiction, you can likely resolve this issue and ensure that the installation complies with all applicable regulations. Remember to always consult the latest edition of the National Electrical Code and any local amendments to ensure compliance with the most up-to-date requirements. When dealing with electrical inspections and code compliance, clear communication and a thorough understanding of the relevant regulations are essential. The key is to demonstrate that the installation meets the safety requirements of the National Electrical Code while also adhering to the specific guidelines for low-voltage Class 2 circuits. Remember to document everything and maintain a professional approach. Here's a more detailed breakdown of the code sections and related considerations. Firstly, regarding National Electrical Code Section 501.6c, it's important to note that Article 501 pertains to hazardous, classified locations. These are areas where flammable gases, vapors, or dust may be present, creating a risk of fire or explosion. Unless the kitchen remodel falls within such a classified location, this code section would not apply. Secondly, National Electrical Code Section 725.158b2 specifically addresses the installation of Class 2 and Class 3 circuits. These circuits are defined by their voltage and current limitations, which are designed to reduce the risk of electrical shock and fire. Class 2 circuits, in particular, operate at relatively low voltage and power levels, making them inherently safer than Class 1 circuits. The reference to Articles 725 and 727 is crucial because these articles provide the specific requirements for installing Class 2 and Class 3 circuits. These requirements often differ from those for high voltage circuits, reflecting the lower risk associated with these circuits. Thirdly, when considering the use of Romex cable for low voltage applications, it's essential to verify that the cable is appropriately rated. Romex, also known as non-metallic sheath cable, is commonly used for residential wiring, but it's important to ensure that it's suitable for the specific voltage and current requirements of a Class 2 circuit. The cable's ampacity, or current carrying capacity, must be sufficient for the load, and the insulation must be rated for the operating voltage. Fourthly, it's also important to consider the National Electrical Code requirements for overcurrent protection. While Class 2 circuits are inherently safer than higher voltage circuits, overcurrent protection is still necessary to protect against faults or overloads. The size of the overcurrent protection device, such as a circuit breaker or fuse, must be appropriate for the ampacity of the wiring and the load. The National Electrical Code provides specific guidelines for selecting overcurrent protection devices for Class 2 circuits. Fifthly, the National Electrical Code requires proper grounding of electrical systems to ensure safety and prevent electrical shock hazards. While Class 2 circuits may not require the same level of grounding as higher voltage circuits, it's still important to ensure that the system is properly grounded in accordance with the National Electrical Code requirements. This may involve grounding the transformer or other components of the system. Sixthly, when installing low voltage wiring, it's important to follow the manufacturer's instructions and recommendations. The manufacturer may specify the type of wiring that should be used, the methods for connecting the wiring, and any other specific requirements for the installation. Following the manufacturer's instructions will help ensure proper performance and safety. Seventhly, the authority having jurisdiction plays a crucial role in interpreting and enforcing the National Electrical Code. The authority having jurisdiction is the local electrical inspector or other official who is responsible for ensuring that electrical installations comply with the code. If there is any disagreement or uncertainty about the code requirements, it's always best to consult with the authority having jurisdiction for clarification. Eighthly, documentation is essential for any electrical installation. Keep records of all wiring, connections, and equipment used in the installation. This documentation will be helpful for future maintenance and troubleshooting, and it may also be required for inspection purposes. Ninthly, a professional approach is essential when dealing with electrical inspections and code compliance. Be polite, respectful, and cooperative with the inspector. If you disagree with the inspector's interpretation of the code, present your arguments clearly and respectfully, and be prepared to provide supporting documentation. Tenthly, always prioritize safety when working with electricity. If you are not comfortable working with electricity, or if you're unsure about any aspect of the installation, it's best to hire a qualified electrician to do the work. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others from electrical hazards. In conclusion, while the inspector's initial assessment might lead to the assumption that sleeving the 12-volt wiring is necessary, a closer examination of the National Electrical Code, particularly Article 725 concerning Class 2 circuits, reveals that this is not typically required for concealed wiring. By presenting these code references and maintaining a professional dialogue with the inspector or the authority having jurisdiction, the situation can likely be resolved, ensuring compliance with all applicable regulations and prioritizing safety in the electrical installation. Understanding the nuances of the National Electrical Code is paramount, especially when dealing with low-voltage systems, as the requirements often differ significantly from those governing higher voltage installations.